Full introduction to MITRE ATT&CK. Coming from us from IBM Security as the lead architect, please welcome Jason Keirstead.
Hey everyone. So hope everyone's having a good time today, learning a lot. My name is Jason Keirstead, and I'm here to give what I call a gentle introduction to MITRE ATT&CK. What do I mean by gentle? Well, so I'm going into this assuming you know nothing about it whatsoever. I was just talking to a gentleman earlier, actually, he didn't know what even MITRE was. So if you already know what it, so first of all, does anyone here even know what ATT&CK is besides myself? Good, excellent. Because if everyone raised their hands, there's probably no reason to be here. But for those of you who might not even know who MITRE is, MITRE, I'll just spend a couple of seconds about it, because I guess I may have read something else. So MITRE is, they're called a federally funded research and development center in the United States. They do a lot of work for the United States federal government in terms of a number of different things. One of those is cybersecurity. So if you've ever heard of a CVE vulnerabilities, that's a MITRE invention, CVE. They developed CWE, they do a lot of work for NIST, things like the NIST cybersecurity framework. They developed standards like they initially developed standards like sticks and taxi for threat intelligence sharing. So they're involved in a lot of work when it comes to cybersecurity information sharing and standards efforts. They created this framework a couple of years ago called ATT&CK, which I'm going to talk about today. I'm going to talk about what it is, why it'd be interesting to you, et cetera, et cetera. So how am I going to structure this talk? I always find when you're trying to learn about something new, it's good to start with the 5 W's. Who, what, when, where, and why. And there's also the H in there that people sometimes forget, the how, which is very important. So this is what we're going to talk about today. Who am I, first of all? What's MITRE ATT&CK? When and where would I use MITRE ATT&CK? Why is it advantageous? Why is it important? And how does it break? How can it break? What are the things that you want to be aware of if you're going to try to use this framework in your organization? So let's start with who I am, why I'm here talking to you today. My name is Jason Keirstead, as I mentioned before. I work for IBM Security, and I have since 2004, back when we were QM Labs. We later got acquired by IBM in 2011. A lot of folks here know this story. Over the years, I've been involved in a large number of different initiatives at IBM Security. And over the past few years, I've had the pleasure of falling into this role as the threat intelligence focal for standards across the IBM Security business unit. And in that role, working with people from MITRE, working on sticks and taxi and all these different standards, I presented a number of different conferences on this topic. I'm also a recently elected member of the board of directors of OASIS, which is the standards body that creates all these standards. They also standardize things like XML, which I'm sure you've probably heard of, and work on things like sticks and taxi and whatnot. I also want to give credit where credit's due. Before I get started in the meat of this presentation, I want to acknowledge that both John Wonder and Katie Nichols, colleagues of mine who I know at MITRE, provided some of the materials used in this talk, so some of the graphics and some of the concepts, and they, when they presented this at Las Vegas BSides last year. So, what is MITRE ATT&CK? What are we here talking about? What is this thing? So, let me start by framing the problem that we all have as security practitioners. What keeps you awake at night, right? What do we go to sleep dreading that we're going to have to deal with the next morning? How effective are your defenses? So in your environment, in your network, how effective are the things that you procured and the tools and techniques that you have deployed? How effective are they actually going to be? Oops, I clicked Could you detect the next friendly rabbit, squirrel, or brokeback hippo, or whatever the next crazy name that Symantec or FireEye is going to come out with the next advanced persistent threat? If that happened in your environment, could you actually detect it? Is the data, all this data that you're collecting in your security environment, logs, flows, stuff from your endpoints, stuff from your Windows events, your SQL Server logs, you're collecting all this data most likely. Is it actually useful? Are you getting any value out of it? Do you have obvious gaps in your cybersecurity landscape? Do you have overlapping tool coverage? So are you leaving yourself wide open in one section of your environment, and yet in another section of your environment you have 3 different tools and techniques that do the same thing? When you're a small company, this is less, this is something that you run into less, but as you start to grow and you start to get into the enterprise, it's extremely common that tools that you bought a couple of years ago have been upgraded, and now they have capabilities that overlap with another tool that you have, and you're doing the same thing 3 different ways, and potentially introducing all this new data that your SOC operators have to deal with as a result. So finally, final part of the problem, will this shiny new product from one of those vendors up in the lobby there really help with your defenses? The marketing says one thing, but will it actually help me? Is it something I actually need? So this is kind of the problem that we're trying to deal with when we talk about MITRE ATT&CK and what we're looking at here. So what is ATT&CK? Let's try to answer that question. Let's start by saying what is not. ATT&CK is not a threat intelligence feed full of IOCs to look for. It's not an alert generator. It's not something that says, hey, if you look for all these bad guys, you're going to find the next threat. If you look for these URLs and a IP address in your environment, you'll find a threat. So send an alert on that stuff. That's not what MITRE ATT&CK is. ATT&CK is also not a kill chain system that describes an event lifecycle. So do folks here in general know what a cyber kill chain is? Starts, so 3 folks. So the cyber kill chain is, and I'm going to have a graphic up on the next slide that shows shows the cyber kill chain. It's essentially a series of things that occur whenever an attacker breaches a network. And it starts with reconnaissance, when they're trying to figure out how to get into your environment, moves into a number of different phases, including weaponization, where they deploy something in your environment, and there's persistence when they try to establish a foothold and keep that tool in your environment. So it's this, I don't want to go too much into the weeds of what the kill chain is, because MITRE ATT&CK is not a kill chain, is the point. It's not trying to describe an incident at a high level like that, and the reason why is to become obvious shortly. So, ATT&CK stands for Adversarial Tactics, Techniques, and Common Knowledge. That's what the acronym means. And what it is it's a globally accessible knowledge base created and curated by MITRE that attempts to catalog all of the tactics, techniques, threat actors, and malware and tools that are used in the wild today in real-world events, and organizes all that into an easily consumable model that anybody can adjust for free. ATT&CK is based on real-world, in-the-wild observations of actual behavior. So when MITRE initially created ATT&CK a couple years ago, it was based on everything that their SOC sees every day. And MITRE is a huge organization. They have, I think, 30 or 40,000 employees. So, it's a very significant SOC. They have a very large coverage envelope. So all of the incidents that they were seeing every day, they started cataloging them and creating this matrix of all the different techniques that attackers use in your environment. So that's an important point. It's based on real world. This isn't theoretical. It's constantly being updated, but when it is updated, it's being updated with the latest incidents that are coming out from different vendors, such as Symantec, FireEye, IBM, etc. And finally, ATT&CK is It's focused on the adversary and the behaviors they present. It's not based on the defender, right? So attack is interesting, and hopefully you'll see why through the presentation. The reason attack is so interesting is because it's not coming at it from our perspective. It's coming at it from the attacker's perspective, right? And if you really want to get ahead of the threat, you have to shift your thinking and think like an attacker, as opposed to thinking like a defender. Because the defender is always playing catch-up, right? The attacker is always in the leading position. So you want to think more like an attacker. An attack is all based around the techniques that attackers use and the ways that they chain them together to create threats. So by thinking about things that way, you put yourself in a better position to create your defenses. Finally, attacks, community-driven and updated by MITRE. So it's being continuously updated. They update it at least once a quarter, sometimes more often. All of the data that backs attack, like I said, it's all free. It's actually available on GitHub, so you can check it out. It's all encoded in JSON, very easy to ingest into tools and create your own reports on, and they have a very nice website that lets you even look through it and run searches and reports for your operators in a human-readable format as well. How attack is laid out. If you go to the attack website and take a look, you're going to see this matrix. This is basically how attack looks when you view it in a spreadsheet form or on their website. It's a matrix that has various tactics as columns, and I'm going to go, don't try to read this blurry picture. I'm going to go into what the tactics are in a second. Each tactic has a list of what is called techniques below it, and those techniques are in no particular order, so the ones at the top aren't any more important than the ones at the bottom. They just kind of add them to the bottom as they find new ones. And these techniques, so these, in this picture here, that's very fuzzy, every one of these table cells would be a technique. And those are the things that attackers use to get into your environment. And they're the things that you want to look for to try to catch those attackers and create alerts around those. Also, as part of attack, so these are all the different techniques that attackers use to get into your environment. As part of this as well, I mentioned MITRE actually catalogs all of the known threat actor groups and campaigns that are in use in the wild, and what malware they use, and how they map to these techniques. So if you actually go and look at the data that builds this matrix, there are over 280 pieces of malware that have been cataloged, and there are over 80 different adversaries that are cataloged. So all the different threat groups that are going and launching these attacks, you can actually go and find out what tools they use to launch these attacks and how those tools operate in your environment. And again, all for free. All of this is freely available. So I mentioned earlier the cyber kill chain and how attack is not a cyber kill chain. But for folks who do know what a cyber kill chain is, it's important to kind of briefly explain where it fits along the threat lifecycle. So this blue arrow at the top represents what's called a cyber kill chain. Again, without going into too much details about that, anything that ever breaches your network goes through this series of steps, right? An attacker first will do some type of reconnaissance. They'll then weaponize a piece of software. They'll then deliver that software to you somehow via either sneaker net, or they'll hack in and find a breach or a vulnerability and deliver that. After they've delivered that, they'll try to exploit something, right? After the exploit, they'll try to control something, right? So once you've exploited a piece of software on an endpoint, the next thing is you want to establish some type of control. So you want to make yourself administrator or make yourself a root or whatever. After they've executed control, they'll try to execute their attack, and then they'll try to maintain a foothold through persistence. So they'll try to take their endpoint that they've taken control over and maintain their foothold on it by putting stuff in the registry or renaming executables or injecting malware inside existing software, so that the next time you reboot that, it'll still be persistent. So that's a side of the kill chain. Attack is focused very much on the right-hand side of that. So attack doesn't focus on the recon and weaponized phases of the kill chain. So you're not going to find anything in attack about, you know, scanning or, you know, probing networks or doing brute force attempts or social engineering, stuff like that. They focus very much on the second phase. They do have a thing, though, called pre-attack, which MITRE is working on. I would say it's in an earlier stage of evolution than attack. Attack is becoming very widely adopted across the cybersecurity space worldwide, while pre-attack is a little bit newer. So these here are the different tactics that are mapped in attack and how they categorize themselves. So that blurry table that I was showing earlier, these are the column headers of that table. So there's a tactic called initial access. So that's basically how somebody initially gets into an environment. Execution, how they go and they run their attack. Persistence, how do they take their exploit and make it persistent on the endpoints that it'll live across multiple logins and repeats. Privilege escalation, so that's a tactic around, you know, I come in as a nobody user and I want to assume the credentials of a root user and administrator. Defense evasion, how do I hide the fact that I'm in this environment? How do I make myself invisible to your defenses? Credential access, once I'm in the endpoint, how do I get access to credentials for other users so I can start moving laterally across your environment? Discovery, how do I discover what assets you have so I can decide where I want to go next? How do I find out where your database servers are? How do I find out where your credit card information is? Lateral movement, so that's what I just mentioned about how once you come in and establish a foothold on one endpoint, you want to start to move laterally into these other servers and systems to try to gather more and more information. Collection, so once you move laterally and you have access to all these databases and whatnot, you know, you've actually got to collect that information and exfiltrate it out, which is the next step. You know, that actually requires some thought because you're trying to evade defenses at the same time. You're trying to collect all of this credit card information or PI or, you know, IP secrets and exfiltrate it out of the network without being detected. And then command and control. So once you've done all of these things, you've exfiltrated your information, you want to establish a command and control channel back to home base so that, you know, I can launch another attack in this environment in the future. And that might be done via IRC, Twitter, Facebook, Reddit. There's many different ways you can do command and control. So all these tactics, right, there's dozens of different techniques that attackers use for each of these things. And that's what attack is. The attack framework is about taking these tactics that everybody uses and then cataloging all the different techniques that they can use to do each of these things. And the reason you want to do that will become obvious as we go through here. So what does a technique look like? If you actually go and you drill in on one of those little table cells, this is the information that's behind it. So you'll have, you know, the name of the technique, a high-level description of what the technique is. So in this example here, we're going through the new service technique. So as an attacker, you go in, you exploit something in a Windows environment, you gain a foothold. You probably want to, one of the methods of persistence is to install a new service in Windows. Give it a name that probably nobody will detect, right? Because that service will start up at boot time. There's a description of the technique, platforms affected, you know, that can go through Windows, iOS, Linux, all kinds of different operating systems. There's permissions required and effective permissions, which are different, right? Or they can be different. So to install a new service, you need administrator assisted permissions, but the effective permissions after you've done that are the system, right? Because services run at the system They go into how to detect this technique, how to mitigate the technique in your environment, the data sources that you use to do that detection, right? And then, once again, examples of all of the different threat actor groups that have used this technique in the wild. And again, I'll just briefly bring up that picture that I had a little while ago. So that table, all of those table cells, every single one of them has this level of detail behind it. So I mentioned as well that they also catalog the groups and software that leverage these techniques. So if you drill into the group, you can see what the name of the group is, what the description of that group is, and what they've done in the past. So in this case, we've got the ATT&CK group. They've compromised the DNC. They're the group that compromised the DNC in the United States in April 2016 at the election. They've also been involved in a lot of other activities. And if you look down at the aliases, you can see that this group, which MITRE is calling ATT&CK, is known in the wild by a whole slew of different names. So if you see an article about Fancy Bear, or Threat Group 4127, or So Fancy, all of these different aliases are referring to this group. So basically what MITRE is trying to do here is catalog and normalize all the information across all these different cybersecurity companies. So FireEye, I believe FireEye is the one that calls this Fancy Bear. They're the ones that first detected it, and they named it Fancy Bear. If you go and look at Symantec, Symantec's threat reports, they probably have a different name for it. And us at IBM MITRE is probably a different name for it as well. We probably call it IBM-TG something or other. What MITRE is trying to do is normalize all this so that, when you get these reports and when you're looking at things in the news and you're trying to trace down what's happening in your environment, you can also use a common language, right? Because, inside your community and who you're collaborating with, you might have different tools, right? You may work with different vendors. And you don't want to have a lack of a common language to be an inhibitor as you're trying to collaborate with your peers. Finally, they also enumerate the actual software. So this is an example of Chopstick. So Chopstick is the software that's used by that threat group. So this is a piece of malware. These are all the techniques that Chopstick is used in. So it's used to obfuscate data, it's got a proxy in it, it's got remote file copy in it, it leverages run DLL32 to persist itself, it does screen capturing, it does credential dumping. Obviously it's a pretty bad piece of software. You don't want this in your environment, right? So part of attack is not about, a signature to detect Chopstick. It's about what are the things that Chopstick does in your environment, right? And how could you detect those? So it's about moving up a level as opposed to, looking for file hashes and looking for IPs. You want to look for the behavior. So now that we know what attack is at a really high level, when and where would you use it? What is this useful for? So there's a lot of different ways you can use attack. I'm going to focus on the three most common use cases that people use it for: detection, measuring defense, and evaluating tools. So first, detection and analytics. Who here recognizes this picture? Does anybody here know what this picture is? Okay. This picture, it's been around since 2013. So it's very well known in the cybersecurity industry. It's called the Pyramid of Pain. It was developed by a guy named Dave Bianco, who's one of the thought leaders in terms of threat intelligence worldwide. Dave created this idea of a pyramid of pain where if you're an attacker and you're trying to get into someone's environment, there's a level of pain that you incur as people start to defend against you, right? And that pain involves what's the most easy thing for you to change. So if I'm an attacker and I'm attacking you, and you started detecting me, what's the easiest way that I can evade your detection, right? It depends on what you're detecting. If I have a piece of malware, right, and I use that malware to exploit people, well, how easy, and the way they're detecting me is because their antivirus is detecting the file hash, right? So anytime I see this executable, I'm going to alert. Anytime I see this executable, I'm going to alert. Well, my malware is useless now, right? Well, how easy is it for me to evade that? How easy is it for me to change a file hash? All I got to do is like change a string and recompile. Now the file hash is different. Now no one can detect me, right? So that's extremely trivial for an attacker to evade that defense. Next level up, IP addresses. It's a little bit harder to launch my attack from different IPs. But nowadays, it's pretty easy, right? With cloud, AWS, Azure, and free accounts. I can go and sign up for a free AWS account and spin up a VM and launch an attack in probably like under 5 minutes, right? With automation. So it's pretty easy to switch IP addresses now. A little bit harder than file hashes, but still pretty easy. Domain names, okay, now we're starting to get a little bit more difficult, right? So domain names as a command and control, if you're detecting, if I have a domain name, and that domain name is used for command and control back to my environment, it's a little bit harder for me to change that rapidly, right? Because I gotta go register new domains, I gotta pay for them most of the time, things of that nature. So it's a little bit harder, but if you're an advanced threat actor, it's actually not that difficult because you can buy domains in bulk very cheaply now. For like, $100, you can go and get like bundles of domains that are unused. And you can automate all this nowadays. You can automate the procurement of domains. So it's harder, but it's still fairly low. Next level up, we're getting into things that are a lot more difficult, right? Network and host artifacts. So if I have a piece of malware, it's really hard to hide the way that it operates on the network, right? So that command and control channel, it might be really easy for me to change the domain it's talking to. It's harder for me to change the traffic, the signature of the traffic that it's going into, because it's part of the malware itself. So that's hard to change. It's getting a little bit easier with encryption nowadays, and transparent encryption everywhere. But it's still harder. Tools and TTPs, these are extremely difficult to change because this is basically how my threat activity operates, right? What's the tool? Well, it's the tool that I'm actually using in your environment. What's TTP? TTP is the technique and procedure that I'm using to get into your environment, right? I'm using this vulnerability and I'm taking this software and deploying it, and then I'm reaching out to this environment. It's the whole signature of my activity, right? That's not something that I can probably change. So if your detections are detecting TTPs, then I'm probably screwed. Because I can go and change IP addresses and file hashes and domain names till the cows come home, but you're still going to detect me, right? And that's because you're not looking for these ephemeral things. You're looking for my behavior, right? So, getting back to attack and how you use this for detection analytics. Analytics are is the name of the thing that we use to look for a technique. So a technique, something like that remote access, right? An analytic that would look for that technique would be something like the above. It would be say you're looking for Windows logs that start with, that are login type of remote interactive. That's the type of log that Windows creates when someone opens an RDP session to Windows box. If you create an analytic that looks for that, this is very basic. But that would be an example of an analytic looking for a technique, and that technique would be a remote access. Again, very, very basic example, and usually you'd want to have a whole bunch of parameters around that, right? To whitelist out people are supposed to use RDP and automation systems that are allowed to use it. and that's what we're talking about the next bullet there. Many of these analytics that you want to use to detect techniques in attack, they're very high level general purpose on purpose. And they'll result in false positives if you just go and blanketly look for all these things. So it's not as simple as I want to go and start looking for all these different techniques in my environment, because you'll just create alarms at the wazoo. What you really want to look for as you try to look at these techniques are chains and groups. And the way you can do that is because, like we were talking about before, MITRE has actually encoded all the different threat groups and the techniques that they use. So you can actually go and start creating analytics that look for chains of techniques. And once you start to see a pattern, well, I'm not just seeing an RDP login. I'm seeing an RDP login followed by this other type of event that I know that this threat actor group used to establish persistence. And then I'm seeing this other type of mysterious network activity out to a domain I've never seen before, which matches a command and control channel technique. Once you start to see chains of that behavior, you can now have the confidence that you want to say, you know what, I want to create an alert, I want to alarm, I want to start investigating that. So you've got all these techniques now, and you're all going to go to the MITRE website after and find out about all these techniques and try to find ways to create analytics and search for them. What are the steps you have to go through if you're going to develop that analytic? So the first is read the page and fully understand what they're talking about with the technique. Think about it from the adversary's perspective, not the defender. So again, attack is all about the adversary's perspective, and you want to think like an attacker. You don't want to think like the person who's trying to defend against your environment. Try to mentally separate in your head, what would this look like if someone was using this thing and this technique nefariously, versus what does it look like if this is just happening in my environment as a course of day-to-day operations. Next step is you can try it. So do anyone here practice red or blue team exercises where you go and you try to penetrate your environment? MITRE attack, and I'm going to get into that in the second use case for attack. You can use these tools created by Red Canary and Endgame, Atomic Red Team and Red Team Automation. They let you structure your red team activities around MITRE attack, so that when your red team creates reports to give to your blue team, well, this is how we got in. All of those things that the red team does can all be mapped back to techniques in attack. And it lets the red team and the blue team speak this common language so that you can go and create your defenses in a more structured way. But while you're developing these analytics and using these tools, you can use them to figure out, okay, if I go and I run red team automation against my environment, what does that look like? What type of logs does Windows spit out when I go and I run this specific technique from the RTA toolkit? What do I see on my network? What type of activity do I see exfiltrate? Could I write rules? Could I write alerts to look for that? Could I search for that information? Finally, you then want to start writing it. So you'd want to write your searches in your SIM or your Elasticsearch cluster or wherever you're storing your log data. Write rules, write alerts, try to narrow down the false positives, and iterate and keep testing. Try to find a variety of ways it can be used, not just the easiest way. Once you deploy your technique and start looking for it, if it gives false positive, continuously tune it. The whole thing is an iterative process, so you're going to be continuously refining this. Use case 2. So this is where we get into red and blue team. Measuring your defense. So once you've got defenses deployed and all of these analytics to detect these techniques, how do you measure them? How do you improve them over time? With a structured framework and regular testing. That's how. So the attack matrix combined with MITRE's viewer, right? So another part of this is they have this whole interactive viewer that lets you view the elements in this table and color code and highlight them and shade them. And if you combine the matrix with that viewer, it creates a powerful tool that lets you report on your current defenses and report an outcome of your red and blue team activities. So you could create reports for management around your coverage. You could say, here are all the techniques that we know we're looking for right now. And here are the techniques where we know we have gaps. And you give that to, and first of all, you can create reports for your management to help you justify purchase decisions. Second, you can give that to your red team, and your red team can use that to structure their exercises. Well, you know, we're going to go and test him where he's weak, or maybe we're going to test him where we know he's not weak, or we're going to exercise what he says he can do. We're going to exercise his defenses and see if they're actually as good as they think they are. And then after the red team activity is done, attack lets you create, you know, again, it's all about that common language. It lets your red team and blue team speak to each other in a common language, and you can collaborate with your peers as well in industry and inside your community. So attack, again, lets everyone speak the common language so you can say, you know, we had a red team exercise today, you know, we found these problems, you know, you've been seeing, you know, do you have any ideas on how we can improve on these specific techniques? Measuring defense. So I actually I mentioned this, I went ahead of myself. So the blue team can map their gaps back to their analytics, the product's environment can be tuned to detect these things. Final use case, evaluating your tools. So using attack, you can plan and structure your product evaluations because you know in advance what you're going to be evaluating your vendors on. You can use the framework as a structure to give reports to management, you know, more visual language that they understand. You know, sometimes it's a lot easier for the CISO to understand a heat map of red versus green than a whole bunch of words on a page about where your gaps are. You know, interestingly, MITRE has actually recognized this part of the value, and they've created this independent testing program that's starting to roll out across the industry. And you're actually probably going to start to see vendors use this in their marketing more frequently. You know, two of them here are already doing it, as you can see. If you go to Endgame's website, they like to talk about their attack coverage. If you go to CrowdStrike's website, they're now starting to talk about their attack coverage. So you can expect to see this start to permeate as this gets more and more traction, because you know, it's a very easy way for people to understand what their tools actually do, right? The cybersecurity market is enormous, and there's hundreds of startups every year, and the number of tools that overlap with each other, it's you know, and getting through all of the marketing, sometimes it's really hard to understand what a company actually does, and attack creates a very well-structured way that companies can talk about what they do and what techniques they help with. So all that sounds great, but like anything else, there's challenges and pitfalls you have to watch out for if you're trying to leverage attack. If you just go willy-nilly and try to roll this thing out, attack could actually hurt your security program rather than help it. So I'm going to go over some commonly seen challenges that people run into if they're trying to use the attack framework. So the first pitfall is assuming all those techniques are equal. So like I said, there's this matrix of techniques. They're in no particular order in terms of the matrix that are just kind of bolted onto the bottom as new ones are discovered. But they're not all equal. MITRE treats them as equal, but they're not, right? Techniques in attack don't have any kind of severity rating. In my opinion, they should. Because some techniques are much, much easier to deploy than others for adversaries, and some are much more, have much more far-reaching consequences than others. Some techniques are like entire programming languages. Like they actually call PowerShell a technique, right? You know, that's, you know, you can do almost anything with PowerShell. So that's the first gotcha is don't assume that all those things are equal. You should, read through them, understand what they're talking about, and prioritize them with context relevant to your environment. Another red flag that people run into is assuming they're covered because they can detect a technique in one scenario. And this is the thing you have to watch out for with these heat maps. So if you're using MITRE's tool to view your coverage or view your activity reports after your red and blue teaming, and you've got a whole bunch of the cells are greening. Okay, we're good, we're greening. No. That just because you have a technique covered in one specific scenario does not mean that you will cover it for all future scenarios. You're never going to gain and maintain 100% coverage of any of the techniques, let alone all of them. It's a continual process, and coverage is best thought of as a continuum. It's not a binary. It's not am I covered or am I not? It's about am I more well covered in this technique than in others. Finally, another pitfall is assuming that you need alerts for every single technique. So that matrix is enormous and growing all the time. If you create alerts for all of those things, you're just going to create false positives all over the place, and your SOC's going to hate you. And many techniques have positive uses as well. So we were talking about remote access, right? System administrators use RDP all the time. You don't want to create an alert every time someone does RDP, right? So, you want to evaluate these chains and groups of techniques, if you can. You want to, as something progresses through the kill chain, and you're seeing activity that is closer to a TTP, so you're seeing more and more things that are adding up to that adversary's behavior, that's when you want to alert. And so those are some of the pitfalls that people run into when they're rolling out this stuff. Some of the challenges that you're going to have are around evaluating these analytics and chains. So, they often require increasing amounts of data. Properly developing these analytics, needs data from your endpoints, data from network, data from threat intelligence, and collecting and marking all this information can be difficult. It can be, it can also be expensive. It's not free to collect logs forever, right? But some food for thought there is, can ATT&CK actually help with the problem, right? Can you target your data collection and the log sources you're collecting from using ATT&CK as you look at your coverage? As you look at your coverage in your environment, now that you have the structured way to go and look at how covered you actually are, it can help you with things like, what logs are important and which ones are not as important. If I already have a tool that's deployed in the network that gives me very good coverage of this technique, do I really need all those logs to also go over here with rules and create duplicate alerts, right? Maybe my resources are better spent, trying to detect this other technique which I have no coverage for at all, and it's just as important. Finally, community. So, as we go down this journey and we start to develop these analytics to detect these techniques, it's very important that we develop communities around these things, because no one company or environment can do this themselves. People need to collaborate and share. But there is a challenge around bridging this asymmetric information gap, because people have a hesitancy to share analytics because they think that it's going to let the adversaries know how they're defending themselves, right? I don't want to talk to, I'm Bank A, and I don't want to talk to Bank B about, my MITRE attack coverage and analytics I've deployed, because then Bank B will know what tools I'm using, and maybe that information will get leaked. And then my adversaries will know what tools I'm using, and they'll be able to, figure out ways to work around it. This is a big problem that we have in the industry today. I think we have to, this is something we're going to be continually working on, I think, in the industry. How can we develop robust trust communities that can create, evaluate, and share these things in a trusted manner? Because, our adversaries collaborate, and build and sell these toolkits in the marketplace, we have to be able to do the exact same thing for our analytics, or we're never going to be able to keep pace with them. So that's pretty much my presentation today. I have here a list of a slew of resources that I've been referring to throughout this presentation. And I think these slides are all going online, so you'll have links to all of this stuff. So there's the MITRE website. Here's a very cool tool called Detection Lab that leverages ATT&CK. I mentioned Atomic, Red Team, and Endgame. These are two, very great open source tools to launch red team attacks against your environment. Some cool playbook viewers from Palo Alto and FortiGuard. Cyber War Dog has some playbooks as well. So all of these are playbook viewers that let you view the life cycle of an APT through attack. And then finally, there's a really cool thing that was released a couple weeks ago where someone has gone and mapped all of the audit D events in Linux to attack techniques. So you can go and take those audit D events and feed them into this framework and this rule, and it'll tell you all the different techniques that those audits line up to. And with that, anyone have any questions? Questions about attack or how you leverage this? I confuse everybody. Yep. About, sorry, what was it? About Jupyter? Jupyter notebooks, or what's around MITRE? Oh, okay. I think you're referring to Jupyter notebooks. So Jupyter notebooks are they're a big data analytics framework that let you kind of like write Python code live and test it against data sets. And there's a number of Jupyter notebooks that have been released that let you work on analytics targeted towards attack. So when we're talking about these, let's go back here a little bit. When we're talking about developing analytics, the word analytic is a little bit of a loaded word because it can be as simple as looking for a Windows log, or something more complicated like, okay, I'm going to look for this firewall behavior and a Windows log. Or it can be, okay, I'm going to go and develop an algorithm in a Jupyter notebook that reads all of my log data for the past 6 months and runs it through this Python code and tries to detect outliers and things like that. That's also an analytic. So when I'm talking about analytics, usually people are starting from the searches and rule side and the basic use cases. As you start to get more advanced, you're going to want to look into things like Jupyter notebooks and developing. It's basically writing code. You're writing code to detect the TTPs that the adversaries are using. Does that help answer your question at all? Any other questions about tactics, techniques? Good question. While I was preparing this presentation over the past week, I actually, and I was working through, you always have to have challenges in a presentation. You want to say everything's good. So I was like, okay, I need to write a challenge section. I started thinking and writing and stuff. And when I realized that was a big problem in attack, I actually reached out to John and I said, are you guys thinking about this? And so they have thought about putting severities. They're challenged with the fact that it's very eye of the beholder, which things are more severe than others. I suggested to them that they should at least think of it like low, medium, high, because some of this stuff is very obvious, and they're going to think about it because I'm not the only one that brought it up. Yeah, they are thinking about it. I would say that, you know, as you go and you read up on the techniques, you know, anyone who's moderately skilled would it be obvious to them, right?
Some of the titles don't have
Yeah.
obvious.
Yeah. Well, I mean, so they do have a fairly good description, right? This here is truncated. So the description, you know, any individual technique, when you go and look at it on the ATT&CK site, is a full web page. There's a slew of information. So don't assume that just because I've got this in this little table on this slide, that that's all the level of information. There's a lot, for most of these techniques, there's a very robust description, very long description of how you can detect and mitigate those things. You know, so I highly recommend going to the website, attack.mitre.org, clicking into some of these things, doing some reading. If you're anything like me, when I was first introduced to this 2 years ago, and I started reading through, I was just like, holy crap, like, how come no one has ever told me about this crazy repository of information that's all freely available? It was very eye-opening, right? You know, I find that as SOCs start to learn about this more and more, you know, it's a very, very powerful set of information that you can use to help build your defenses.
So there's no knowledge base of like analytic chains. You pretty much need to.
No, there's not. So the question was, so is there a knowledge? Well, there is and there's not. So is there a knowledge base of analytic chains? So there is kind of. So like I mentioned, they actually have all of the different threat actor groups and all of the different software and what techniques all of them use enumerated. So, you know, you can kind of think of, you know, a given threat actor group. This one again is ATT&CK, right? And you can see down here, that group uses these techniques inside this chopstick software that they very often use. So you can kind of imagine if you had an analytic that detected some input capture, and then you had a different one that was collecting, you know, telling you if there was CLIs in use, and there was different C2 channels all being used at the same time, and there was a proxy being spun up and it appeared that there was proxy traffic. You know, any individual one of those, you know, your probably is not really that suspicious, right? You're not going to create a error. But if you see all of those things occurring, well, now, very likely that you're seeing, or at least it's more likely that this is mapping to ATT&CK, right? So that's what I mean when I talk about chains, is looking for multiple techniques either being used in sequence or in tandem. And again, you know, to re-emphasize, like a lot of this stuff, it's not about creating alarms on IP addresses and file hashes or alarms on different things. It's about looking for the behavior. And that's, you know, that's really where you want to be heading. You want to be heading further up that pyramid of pain. All the way back. Where'd my pyramid go? Further up that pyramid of pain, looking more for the behaviors and less for the atomic indicators. Because atomic indicators are extremely, extremely easy for adversaries to change. You know, I can't emphasize enough how useless file hashes are becoming. They're, you know, they're still important. People still use them in tools. You know, our own tools, we're rolling out things with file hashes all the time. But, you know, you can actually go on VirusTotal. If you go on VirusTotal and they have a feed, anybody can go look at this, they have a feed of the most recently submitted malware, you can watch that, right? If you sit there and watch the malware that's being submitted in the VirusTotal, you can actually extract patterns. And there's people who have done research on this, I've seen talks about it. You can see the threat actors uploading their own stuff to VirusTotal, right? Like what they do is they write their malware, upload to VirusTotal, see all the engines, see if it detects any of the engines, and they just keep making subtle changes and re-uploading it until none of them detect it, and then they deploy it, right? And yes, the vendors see that too, and they update their signatures, and then the next day, everyone's protected. But during that window, right, between today and tomorrow, you're wide open if all you're doing is looking at file hashes. And that's the challenge with these things, is it's so easy to evade, so easy to change, right? So you want to move further and further up this pyramid to make your defenses more and more robust. And that's, you know, an attack lives way up here at the top of this pyramid. TTPs and tools. Other questions? Yes, no? Well, I think I'm out of time anyway. So, there's no other questions. Thank you very much. So I'm around. I'm fairly easy to get a hold of. So if you do think of anything later, just let me know.